Hello and welcome to ResearchPod. Thank you for listening and joining us today. The future facing humanity is one of climate change, dramatic population growth, and rapid urbanisation. This has thrown a spotlight on sustainable food production, energy generation, and water provision. Food, energy, and water are not separate priorities, but intricately intertwined, and reducing waste in the food, energy, water, or FEW nexus is a high priority. One project with an international reach and centred around urban living labs, or ULLs, hopes to make a major contribution by developing and testing applicable methods for identifying inefficiencies in a city region's FEW nexus with focus on waste reduction, recovery, or reuse. Today, increased urbanisation and economic growth demand diversified food production. It's no longer directly farm to table. It now follows a convoluted path of processing, packaging, and distribution around the world, adding further need for energy and water use. To better manage our resources, we need to examine the three components upon which we rely: food, energy, and water, not so much as separate domains for research, but as directly interlinked, a nexus. Effective integration of FEW as a nexus also changes practice and performance, and how supply and demand are met, and may increase efficiency and reduce waste.
The concept of a food, energy, water, or FEW nexus is relatively new, and so far has not been widely implemented. Until relatively recently, research, development, and interventions in food production, energy generation, and water provision have been sectoral in approach. The idea that the three are interlinked demands a paradigm shift in the international development agenda, highlighting the increased complexities in addressing sustainability challenges across all three. Clean, fresh water is in short supply, and many of the water systems that keep ecosystems thriving and feed a growing human population have become stressed. Energy, if renewable and correctly managed, can be inexhaustible in its supply. However, fossil fuel production is still a dominant global energy source, and it is highly water-intensive. According to the Organisation for Economic Cooperation and Development, agriculture irrigation accounts for 70% of water use worldwide. Agriculture also remains a significant source of water pollution. Agricultural fertiliser runoff, pesticide use, and livestock effluents all contribute to the pollution of waterways and groundwater. So how do we feed a dramatically increasing global population in the face of climate change when the FEW resources are under considerable strain? One answer is waste reduction.
In terms of food production, energy generation, and water provision and use, current economies are primarily linear. Natural resources are processed and consumed, and throughout the process there is significant waste. If minimising, ultimately eliminating waste is a priority, then an economy should be more circular. Here the focus is on sharing, reusing, repairing, refurbishing, remanufacturing and recycling to create a closed-loop system. This minimises the use of resource inputs and the creation of waste. Given that food, energy and water are interconnected, that most of the world's people live in cities, and that controlling waste is a crucial component to issues of efficiency and sustainability, it makes sense that research is done to develop and test internationally applicable methods of identifying inefficiencies in a city region's FEW nexus. This is the aim of the WASTE FEW ULL project.
The WASTE FEW Urban Living Laboratories project is an international project comprised of teams from Brazil, UK, South Africa, the Netherlands, Norway, and the USA. It is funded via the Belmont Forum and JPI Europe, who convened a global partnership of funding organisations, international science councils, and regional consortia committed to advancing transdisciplinary science to understand, mitigate, and adapt to global environmental change. The project understands that attempts to address inefficiencies in a city region's few nexus will fail if the inherent complexities are ignored. There are no simple plug-and-play solutions, and broad, ill-considered edicts by authorities are likely to fail. At the heart of the project is learning connected with real-world stakeholders and activity, lifting experimentation away from the hypothetical and into real-life urban-based projects, facilitated by the Urban Living Laboratories, or ULLs. ULLs bring researchers out of their academic bubbles and into a range of real-world problem areas. Researchers and stakeholders design and run social, ecological and technological experiments and generate feedback and social learning. For the WASTE FEW ULL project, a key goal was to find solutions that could be scaled up and offered to other city regions to identify and address inefficiencies within their own few nexus. The WASTE FEW ULL project identified 4 urban areas worldwide as case studies: Bristol, UK, Franschhoek, South Africa, Rotterdam, the Netherlands, and São Paulo, Brazil. The project team was aware that collectively, the 4 case studies would represent multiple challenges typically found in other urban areas, and the priorities would need to be different at each ULL, but the same principles would guide their overall methodologies. Firstly, they would each undertake a range of stakeholder engagement approaches, such as developing existing working relations, project meetings, stakeholder recruitment and engagement, and research workshops. Secondly, they would undertake a range of research activities, depending on ULL context and local capacity, skills, and expertise. Thirdly, they would develop impact plans that consider the stakeholders' interests, activities, and risks. Finally, they would form a replicable model and share their methodologies to foster knowledge exchange.
The UK's ULL is in Bristol, a port city and one of the smallest of the UK's core cities. The Bristol ULL team chose waste reduction and resource recovery in the city's waste processing plant as their focus. The focus was on reducing residential food waste and on phosphorus recapture from sewage. The partnership started with 3 centrally active food, energy and water agencies in the city: the Bristol Food Network, a community interest company that connects organisations and community projects focused on transforming Bristol into a sustainable food city; the Centre for Sustainable Energy, a nationally recognised charity that shares knowledge and practical experience and undertakes research and policy analysis in sustainable energy; and Wessex Water, Genco, which owns and operates the city's sewage infrastructure and a major waste processing plant. As the project developed, these were joined by Bristol Waste, the council-owned company that manages the city's waste processing, and Resource Futures, a locally based national non-profit consultancy focused on waste reduction. The ULL was co-led by 2 intermediary agencies, Daniel Black and Associates and the Schumacher Institute, alongside the consortium lead, University of Coventry, which provided expertise in food, water and resilience. They were supported by the universities of Bath, Reading, the University of California, Santa Cruz, and the Centre for International Climate and Environmental Research in Norway. Food waste costs the UK economy billions of pounds each year, and much of it is avoidable. The ULL team calculated that Bristol throws away £150 million of food waste each year. Its 33,000 tonnes of commercial food waste is contaminated by 1,000 tonnes of plastic. The ULLs also showed that it's far more beneficial to the environment if we reduce consumption in the first place, rather than focusing on recycling, but also that existing policy landscapes inherently incentivize more waste, rather than less, increasing consumption, increasing economic growth, and increasing waste. They also found that reducing and recapturing the nutrients from both food waste and phosphorus are essential if we are to address soil depletion. Specifically, phosphorus is an ideal qualifier for a circular economy. It is an essential nutrient necessary for the growth and development of plants and animals, upon which our food supply depends. It is the chief ingredient in phosphate fertilizer, the agricultural demand for which is increasing. However, reserves of rock phosphate are rapidly dwindling. At the same time, in food consumption, humans excrete unwanted phosphorus, which then enters wastewater systems. Too much phosphorus carries serious ecological risks if it makes its way into the waterways. If phosphorus can be economically extracted from wastewater, then not only does that reduce those risks, but it also provides a renewable source of this crucial nutrient for the food chain. The Bristol model holds promise as an international method of identifying inefficiencies in a city region's few nexus because it encourages stakeholders to see the sometimes hidden value of otherwise wasted resources in a system.
Like Bristol, Rotterdam in the Netherlands is a port city, but it is a highly active port, Europe's largest seaport, with all the associated benefits and challenges. One of the biggest problems, if not the biggest, in transitioning from a linear to a circular economy is that solutions don't scale quickly enough, so the Rotterdam Waste Fuel team chose to focus on how to accelerate circular models. The Rotterdam team realised that, given the complexities of a circular economy and the few nexus, projects designed to address inefficiencies usually focus on a specific feature. Methodologically, this makes sense, but such a siloed approach also risks restricting overall uptake. So, the team decided on an impact approach, identifying and developing linkages between projects. To this end, the Rotterdam team used catering services as one example. Based on this case study, they developed novel empirical insights into how to increase and scale cleaner production practices towards a circular economy through circular startups, summarised into a framework with 15 observed principles for connecting and integrating niche innovations to incumbent practices. The approach has wings because there are other cities around the world like Rotterdam, highly developed, forward-thinking cities. Finding ways to connect them to build momentum would help bring about necessary systemic change.
If urbanisation is more rapid in developing countries, then the work of the South African Waste Fuel team holds much promise. The team has chosen Franschhoek, a small picturesque town about 75 kilometres outside of Cape Town. It is also home to Lungrook, or Longback, an informal settlement of about 7,000 people that's underserviced in terms of electricity, water and sewage services. It is also a microcosm of South Africa's urban landscapes. Nodes of development and relative wealth buttressed against ever-growing peri-urban informal settlements, with little in the way of servicing infrastructure. Water runoff from such settlements is usually severely contaminated. To address this issue in Lungrook, the South African team established the Water Hub nearby. Its purpose is to test and develop nature-based solutions to treat the contaminated water runoff. The research aims to determine optimal retention time, volume, and flow in each cell. In line with the concept of a circular economy, this water is used to irrigate vegetables rather than discharging into streams. To complete the circle, energy to pump and transfer water from the river through the filtration and irrigation systems is powered by solar and stored in batteries. The idea behind the Water Hub is to develop processes that such settlements could roll out, independent of government, to make themselves self-sustainable.
Brazil has a high level of urbanisation. Almost 90% of its population live in cities, the most populous of which is São Paulo. It also sits in the wealthiest region of Brazil and therefore enjoys a relatively buoyant economy. São Paulo also sits within the Atlantic forest, which runs along the country's southeastern coastline. Many of the more than 100 dams scattered around the city sit within the forest area and are an essential part of the city's water infrastructure. Just over a tenth of the original forest remains today, eaten away by an insatiable quest for more agricultural land. Therefore, the city offers an ideal space to study the sustainability of an urban area rapidly encroaching on its natural environment. The São Paulo SP in Natura Lab, the city's ULL, decided that preserving the Atlantic forest would play a key role in finding a viable model for the transition to a sustainable food system. Others include using traditional knowledge to apply ecological concepts and principles to farming, finding ways to increase revenues from sustainable agriculture, and developing a network of reliable smallholding farmers by helping secure their land ownership. If an urban area like São Paulo is to reimagine its FEW nexus, focusing on securing efficiencies, it needs the support of its citizens. So the SP in Natura Lab is focusing on changing people's perceptions of transitioning to more sustainable food systems. The team has developed a transition decision-making tool based on 13 sustainability factors. The tool considers using 3 dimensions. Firstly, the physical and material conditions of sustainable food solutions. Secondly, the attributes of community, which is related to mindsets towards such solutions. And thirdly, the rules to use, the effects that agreements, regulatory issues and environmental laws can have in terms of production systems and personal benefits. This model has considerable value if applied elsewhere, because it will help develop the attitudinal framework needed for the necessary changes to address inefficiencies in a city's FEW nexus.
The 4 case studies, Bristol, Rotterdam, Franschhoek and São Paulo, are all live and ongoing. The lessons they are learning are continually feeding into the growing corpus of research into the FEW nexus. They may have different priorities, but their goal is the same: to find internationally applicable methods of identifying and addressing inefficiencies in a city region's FEW nexus. If human civilization hopes to survive this self-inflicted epoch of anthropogenic climate change, it may well need their acumen and insights. That's all for this episode. Thanks for listening, and stay subscribed to ResearchPod for more of the latest science. See you again soon.